to build some type of evaluators. And after we have an evaluator, which looks at the organization and understands its properties, we will have some optimization function. It can be a genetic algorithm, it can be a machine learning algorithm. It will be something that optimizes for something. So that's the premises of any type of optimization, that you have to understand what you're optimizing for. And especially nowadays, machine learning is very popular. And again, machine learning is quite powerful, but if you have quite specific things you're optimizing for. So you have to set up a clear goal of what you're trying to achieve, and you have to set up a few parameters. Think of this almost like things that you can change either at the beginning of computation or during the computation in such a way that the model optimizes itself, right? And in essence, all these things you hear about machine learning, genetic algorithms, even solvers, and there are many types of solvers, like physics solvers, there are constraint solvers, all of them optimize for some result. And it's important for you to develop some ability to write your own evaluators or something that can evaluate something. And again, I'm going to have some basic evaluators, and I'm 100% sure that in your projects, you're going to have more specific ones based on your project brief, what you're actually trying to achieve, right? And I'll show you, I think, two approaches. One with a genetic algorithm, and maybe later on we'll dive in a bit into the machine learning. Now, Unity for this is quite nice because it has a very straightforward implementation for machine learning. I'm a bit cautious because for some reason people have started to think that machine learning is like a magic algorithm that can do anything, which in reality it's not. It can do certain things really well, and some other things you're better off using other algorithms. That's why I would say a clever architect will look into what's available before getting started. So having a bit of understanding of computational model is also useful. So let's start sharing the screen. Okay, so let me switch to maybe one of the is this my I don't remember in which one we were doing the CA. I think it's this one. No, not this one. Maybe this one. Yeah, this one has the stack. Okay, so we can work with this. Okay, clear. Let's do something first quite clever. I have a small camera script that, well, allows me to move the camera around. So let's do that first. So to my camera, I'm gonna add this free camera so I can move around my scene a bit more easier. Okay, so we have our stacking script that, well, is stacks thing, right? Nothing fancy. And what can we evaluate in this? So maybe that's the first thing you should ask. So what is a good evaluator? And for me, maybe because this is a stack, connectivity sounds like a good thing. So I can set up a rule. Let's say if a cell, and I can select any cell. Let's go to the scene. I can easily select them. But if a cell is, for example, connected on 4 faces out of 6, I can consider that one well connected. or let's say maybe 3. So for example, this would be an unconnected cell, right? Because it's not neighboring anyone. And I guess if I go really deep into the stack, and ideally it wouldn't be black, this is a really well-connected cell because this one probably has connections on all 6 sides, right? And let's build that as an evaluator. Let's go into, this is so annoying. Zoom really has to fix this shit. Okay. Just wherever I put it. Okay, so let's start with that. So let's go and build ourselves some evaluators. And I think the logical thing to do is to build the evaluator on the stack itself. And let's create a new C# script. And call this stack evaluator, get our stack. Come on, show me the script. Okay. And let's start to do this connectivity. I would say that's the first one to do. So the cell, we're not doing voice, we're definitely not doing flux. I do need another script open so we can look inside of it. So I'm going to open the, it's my stack. This one, no. All right. So the information I considered exists in this stack layer. So what I'm gonna do, I'm gonna make a reference to it. So that's the first thing I need. And I think the easiest way to get it would be to do something quite simple. Maybe no, we don't need it because we can get it. Well, we'll see if we do it like this or not. Okay, but let's start with something. So let's set up first some input. So we're gonna ask if, for example, we're pressing a key. And I guess let's think. So let's do density first or connectivity. So if I press C on the keyboard, then I'm gonna run a function. I'm gonna run a function that says evaluate connectivity. And now I can do my function. Okay. And at this point, probably I need a stack. So what I'll do in here, I will say, what I call them differently. Copy. Okay, that should fix it. I think getting an error. I'm missing one semicolon. Okay. Yeah. Okay, so I need a game object array of 2 dimensions. And this is going to be retrieved from the CA. And the component we want is the CA, right? And from that, we want the stack. So we're just making a reference to the stack that exists on the CA, right? Now that we have it, let's think of what the rule is. So let's say something like this. And we can say something like this. So 0 is unconnected. And then 6 is super connected. Right? So everything between 0 and 6 will mean a cell is to a degree or another connected or not, right? Now, what's interesting, remember, we have in our actual cell, if we take our prefab, right? So the cell itself, in the cell we have, in the cell script, we have certain variables, right? Like age, youngest, computed. What I could do at this point is to declare for this one a variable, and let's call it connectivity degree. Okay, and we can start at 0, let's say. Okay, so what we'll do now that we have this on our evaluator, we can start to go through the stack and evaluate for each cell what's our connectivity degree, right? So we're gonna need to have 3 for loops. And at this point, it would have been useful to get also the columns row and height, right? So I guess this one, let's get the height first, or I think the way we were doing it, which one is the first one we were doing in the loop? Yeah, so we start with columns, row, and then height. Columns, row, and height. Then the other loop, 0. Okay. And now the last loop. Okay. Now we know each cell is a game object. So that's going to be the stack. And to be honest, I think we can get rid of this to be just more efficient. So instead of making another copy, we can always make a reference to access it directly, which probably is more efficient in terms of memory use. Okay, so stack I, j, k. Boom. So we got the current cell. Now, what we're gonna do, and this is where it gets funny, we're gonna use 3 for loops. So imagine we're at the stack, and I'm gonna check the cells around, the cells on the top, and the cells on the bottom, right? So I need 3 for loops that sort of evaluate up, down, bottom, right? Because I am a bit lazy, I'm not gonna do the evaluation for the cells that are on the border, because I will need to look at the special cases, and that could be something quite interesting. So that could be a nice homework for whoever feels like very brave. So that could be a homework. So to skip the edge cases, I'm gonna start at 1. And I'm gonna stop at -1. Otherwise, we're gonna get a bunch of errors. Okay, so now I got my cell, and I'm gonna evaluate the 9 cubes that are around my cell. All right? So let's comment what we're doing. So here, loop over the cells in the first step is to evaluate the 9 cells around the current cell for connectivity. Okay, so every time I get a cell that is on, I can increase my connectivity number. So I have my current cell, and I'm going to have also an integer. And this is going to start at 0. So the current cell connectivity is 0. So now I'm going to have 3 more for loops. And let's do x, y, z. So x is going to be equal to I -1, because I need to start at 1 before. X is going to stop counting at I +1. Then another for loop, y equals to k -1. Smaller. Come on. One, two, k +1. Oh, come on. This is extremely stupid. Y ++. Thank you very much. Okay, and I need another one. All right. So what we're gonna do, with these 3 for loops, we're gonna get each of the 9 cells that lives around our neighboring our current cell. The current cell neighbor is going to be but instead of ijk, we're gonna have x, y, z. Okay, and this is a game object. Cool. And we're gonna have a very simple evaluation. So if current cell neighbor, and we need the cell component. And from this, we're going to ask, so in the cell, remember, we're asking the state. So if it's 0, it means it's off. 1, it means it's alive. So for this, so if state is 1, then very simple, we're gonna say the current cell connectivity increases. Okay? So after we've done these 3 for loops, what we need to do is to pass the current cell connectivity to the cell itself. All right? And to do that, we're going to say current cell get component type cell, and then connectivity degree is going to be equal to current cell connectivity. That's cool. We've built the evaluator. Now let's actually use it for something. Let's see if this works first. So at least as a number, let's run our code and to see if this actually works. Okay, so the stack has finished building. That's good. C for connectivity. And I'm getting some index out of range, but nevertheless. So let's focus on this. So for example, this one, okay, so something is not going right because I'm getting 0 for this. Let's see what another one, degree, 0, 0. So something is definitely not going okay. That's weird. Yeah, so every time I'm getting index out of range, but it means something in my loop is definitely wrong. Let's see where. So somewhere in here, I think I know why. So we start at -1. Sorry? I can't hear. It's somewhere in here, so I think this has to be smaller or equal, maybe. Let's go back to Unity. Okay, that is done. Okay. Ooh, I'm getting again the same error. And more importantly, I'm not getting my connectivity degree. Let's do a bit of debugging to see why. In here, and let's place this not there. Let's place it here. Oh wow, I'm getting twice there at 45 and at 27. 45 and 27. That's stupid. Okay, so it is calculating. So you see some of them have, but why it is stopping? That's interesting. So I would have expected this to happen a lot of times. So in my stack, I have not only 18, but it did it for 2 cells and then he stops. Okay, so we have a problem in our loop. You see he's only doing it 18 times. So somewhere in our loop, something we're doing wrong here. I know what. We need to stop at that, otherwise it's gonna go above it. Again, well, at least he went to 19 this time. And probably because we need to stop also here. Still wrong. Just for sanity, I'm gonna debug. Let's see how many objects we have in the stack. Okay, so we have 16,000 stacks cells. Is that right? So each layer, I think if something is wrong. 16,000 cells. I don't think we have 16,000 cells. So our stack is 20 by 20 by 40. So each layer is let's do a small calculation. For each layer we have 400 cells and we have 40 layers. Oh yeah, 16,000 cells. Okay, so that's correct. So something breaks our code. So instead of going over the 16,000, he stops after he's done, well, 18 of them. And I'm getting cell degree 10, which I don't think is possible. Because I should have above, oh no, it is possible. So above I have 9, below me I have 9, 18, and 8. So the maximum degree could be 24. Okay, that's actually possible. But then I'm clearly doing something wrong in this guy. Okay, what the hell am I doing wrong there?
Hi, Arturo. I think
Yeah.
for line 41 and 43, you use the K twice.
Oh shit. Yeah, you're right. J. J. Thank you. Yeah, exactly. It should be IJK. Yeah. Thank you. Okay, now it works. And let's check it. So let's check one of these guys, connectivity 4, amazing. So that's good. We have now the connectivity running. And for example, this should have, is it 4 as well? Let's get one of these guys. So this one is 0, correct. So there's nothing around him. Two, let's try to get some of those that are more inside the stack. Something like 6. Okay, so it does work. All right, so now that we built our evaluator, let's also visualize it. So we know visualization is happening directly on the cell, right? So our cells, if we look inside of him, we have here display age, display other things. So let's try to do a function that goes and displays the connectivity. And let's call this display connectivity. Okay. Ta-da-ta-da. And we're going to change something like this. We need to, let's use, instead of edge color, let's call this connectivity color. And the connectivity, yeah, compute color. How did we do it? So whenever we set compute edge color, what were we doing? Let's use, instead of age, let's call this compute color. And in here we can say low value, and in here we can say high value. Okay. RGB value. All right, and then we're gonna use this in, change it in here and in here. And we know this is between 0 and 24, right? Because we know maximum connectivity can be 24. And let's flag this into the blue value. So the connectivity color is gonna go into the blue value. So remember, the age is displayed with red and with blue connectivity, a gradient of blue. Okay, so that pretty much does it, but we need to call in our display cell function we need something similar to this, right? Else if display age, we need something similar to this. So in here, we're gonna change to display connectivity, and we need a Boolean similar to display age. Oh my God, my spelling is probably. Okay, so let's do in our evaluator, evaluate connectivity, but after we evaluate connectivity, we also want to set that Boolean, right? And I think the easier way to do it yeah, I think directly on this could be done. After you've computed the cell connectivity, let's take this out, we don't need it. Okay, so we're gonna tell to the cell to display the connectivity once it's finished computing the connectivity. Okay, there we go. All right, so there we go. It's interesting that it does go with the blue, and with black represents that they're the edge cases. Remember, we didn't do the edge cases? But you get an idea, right? So now I can map quite nicely the connectivity. I think we can also write the function to display the age. So that's quite an easy one to do. I don't really need the update function. So I can do something like this. I can ask something like this. If inputs get key down, and let's use key code A for age. Let's make a function, display age. And display age is going to be very similar to this. Let's make sure we close our loops. And then in current cell, right? So this will trigger the display age. For I guess we need also a normal display. to make things go back to just black. Let's call this 10. And the connectivity is false, false. And by the way, we need also this to be added in here. And okay, so we need one more thing in here. Okay, so when we're displaying connectivity, we're not showing age. When we're showing age, we're not showing connectivity. And when we're showing normal, both age and connectivity are set to false. Okay, let's see if this works. Okay. Well, funny enough, the age doesn't seem to work. Ah, because A is mapped to my keyboard. That's funny. Okay, we need another one for age. Let's do G. Because I have A mapped to my navigation to fly the camera around. Still not working. Well, connectivity is working, but age is not working. But why? So it's ticked on display age, and the age is what's happening? Age 3, age 1. So it is working, but there is something off in my self script probably. Yeah, I'm doing something wrong in the display age. Anyway, someone who's more clever than me can try to sort out what the hell is happening there. Now we have our evaluator, right? And what's interesting, we're displaying the connectivity, but we don't have to wait for the connectivity to finish. We don't have to, we can call the connectivity even as we're building the stack, right? So I can call this function, and obviously it's gonna give me errors because I haven't finished computing the whole thing. But I could change my evaluator to be real time. So every time I make cells, I could compute how connected they are. Okay? And for example, we know that our stack is now using a CA rule, right? Like our overpopulation, correct population, bird population are some numbers. So think of this as sliders, right? Like I could increase this and decrease, right? And I could compute, okay, what rules give me more density? And if my stack is not connected enough, I can increase the density by saying, hey, overpopulation is not 3, it's 5, right? And then my stack becomes big. So the fact that I can evaluate things and the fact that I have some slider-like parameters, these three, allows me to start to change the rules as I build. So my Stellar Automata doesn't have to use the same rule as we go up. And I think what we'll do next week, we'll start to build in a way to change this dynamically as we're evolving the stack. And we're always going to evaluate. So in my current layer, how connected my cell is, right? And we can start to shape this stack that we're building based on some rules. And it can be, I want hyperconnectivity, or I want no connectivity, or I want the bottom part of the stack to be hyperconnected and the top unconnected, or something like this, which should allow us to control the process of building this, right? It will change from just being predefined by whatever the rules are to something dynamic, where the rules can change as you build something. Okay, I think we can stop there. It's good enough for now. Do you have any questions? No questions?
Hi, Victoria.
Yeah.
I have a question about the flocking system you write last sessions.
Questions about what I showed today.
You write a tractor in the void. So if I want to create several attractors with different properties from the voice, so do I need to create another script or just
no, you can have multiple attractors. The difference is that instead of having a reference to only one, you need to make an array of